Psi Access, May 11, 2024. A Universe of Sound, Processing NASA Data into Sonifications to Explore Participant Response. Sarah Kane, Jessica Schonhut Stasik.
Hello, my name is Sarah Kane. I am a PhD student at the Institute of Astronomy at the University of Cambridge. And I'm going to be presenting work that I did alongside Dr. Kane and Jessica Stasik regarding data sonifications of astronomy data from NASA. And I'll get into a little bit of what a sonification actually is in a minute. But it's fair to say, that data sonification in astronomy has become pretty popular recently. I'm just flashing up a bunch of sort of popular science articles that have come out recently about data sonification in astronomy. It's kind of booming these days. But what is this sonification thing that's becoming so popular? Well, in the simplest terms, sonification is the representation of data as sound. And this is directly analogous to data visualizations, which is where we represent data in some visual medium. These are, say, your line graphs, your bar charts, your pie charts. The list goes on and on. There are 1,000,001 data visualizations out there. So this is, as opposed to a visual representation of data, a sound representation of data. Now, what is sonification not? And this is one of the most common misconceptions we come across. Data sonification isn't literally a sound from nature, a natural sound. What do I mean by this? Well, if we're doing astronomy sonifications, this isn't literally the sound of space. It's a representation of the data we take from space, for instance, of the telescope, represented in sound. It's also typically not words, so if I sit here and tell you about our data, that's not really a data sonification. That's kind of just me telling you about it. Now, why would we want to sonify data? This is already data visualization is already a fairly robust field. People are fairly familiar with data visualization, so, if it ain't broke, why fix it? But there are actually very compelling reasons. The one most relevant to perhaps this conference is going to be that data visualizations are, by their very nature, not accessible to people with visual disabilities, people who are blind or low vision. And so data sonification makes that data available to an audience that otherwise wouldn't be able to access it. However, there are other reasons to sonify data as well. For instance, for people who are fully hearing, our ears are more sensitive to change than our eyes. And they also have a higher sort of refresh rate, like if you think of like a screen refresh rate, than our eyes. In fact, data sonification is not some newfangled thing. We've been doing it a long time, and the most famous example is a Geiger counter, which maybe some of you have heard of before. And this is a device that detects radiation and tells you how much radiation there is, ionizing radiation, dangerous radiation, by producing series of clicks. And so if there is less radiation, it'll click slower, and if there's more radiation, it'll click faster. This is a very well-established use of data sonification. And I hope I am sort of preaching to the choir here on this front, but because sonification is useful to both people who are blind, low vision, and people who are fully sighted, it is an excellent example of what we call universal design, which is this concept that when you make something accessible to disabled people, you're actually just making it better. Accessible locations and tools are just better locations and tools. And this is a sort of a concept we've seen play out again and again. My favorite example is always dark mode on like phones and computers. This was originally an assistive technique for blind low vision people. And it turns out that actually everyone just likes dark mode because it's great. And so this is a great example of when you make something accessible, you just make it better. Having sonification is not just for blind low vision people, it is for everyone. And our results will get into that in a bit. So branching off from this idea of data sonification is, we believe, great for blind low vision folks and also for broader communities. Two questions we wanted to answer in our study were, how are data sonifications perceived by the general population as a whole, and also members of the blind low vision community in particular? And also, how do data sonifications affect participant learning and enjoyment, and how will they explore astronomy? How does this type of data representation affect people's interactions with astronomy outreach? Now, how did we approach answering those questions? What we did is we made a survey, and the survey was conducted such that participants heard 3 different sonifications of data. So we had 3 different astronomical objects: the galactic center, Cassiopeia A, and the Chandra Deep Field South, and we had data from each of these, and we sonified them. These are from NASA's Universe of Sound project. And participants in this survey got to listen to each of these sonifications. Now, just a little bit about the Universe of Sound, because I'm not directly involved in the Universe of Sound, and it's an amazing project, so all credit where credit is due. Dr. Kim Arcand and Dr. Matt Russo lead this project along with Andrew Santaguida, and there are also community consultants involved. I will have a QR code to the Universe of Sound at the end here. The sonifications are lovely, and unfortunately I can't play them all for you, so I highly recommend checking it out because it is fantastic project. Now, to give you sort of an idea of what the participants got out of this survey, I'm going to play you one of the sonifications they heard. This is a sonification of data from the galactic center. I am sorry to say that I don't have time to play all 3, though they are lovely. So I'm sorry that I don't have time to play all 3, but I'll play the one of the galactic center. And along with each of the sonifications, participants were given text describing how the data were mapped to sound. So how different aspects of this data were represented in the sound. I'm going to read to you now the description that came along with the galactic center sonification, so you can sort of get a sense of how the sonification is working. Explore the center of our very own Milky Way galaxy. The translation begins on the left side of the image and moves to the right, with the sounds representing the position and brightness of sources. The light of objects located towards the top of the image are heard as higher pitches, while the intensity of the light controls the volume. Stars and compact sources are converted to individual notes, while extended clouds of gas and dust produce an evolving drone. The crescendo happens when we reach the bright region to the lower right of the image. This is where the 4 million solar mass supermassive black hole at the center of the galaxy, known as Sagittarius A star, resides, and where the clouds of gas and dust are the brightest. I'm now going to play the sonification for you. There is also a visualization of the data, like a pretty space picture that accompanies this sonification. So if you are excited, you can look along with that. And I will play that for you now. There we are. All right, so in addition to playing these sonifications, we asked our participants in this survey a series of questions. These included roughly 3 categories of questions. First, some demographics, for instance, their age, their education level, gender, whether or not participants were blind, low vision, or sighted. Then after each individual sonification, so each of those 3 individual sonifications, we asked participants to rate how much they enjoyed, felt like they learned from, trusted each of those sonifications. And then finally, after listening to all 3 sonifications, we asked some overall questions about participants' experiences and also invited them to give some feedback if they were interested. This survey was circulated on the Chandra Telescope's website, a website called Astronomy Picture of the Day, and various social media websites. And our responses were simply a convenient sample of whoever responded to the survey and was over 18 years old. Overall, we had over 3,000 participants, of which 2,988 were sighted and 196 were blind or low vision. Among these people, there was a general predominance of people who had a casual to hobby interest in astronomy, though there were certainly some people who rated themselves as being complete novices in astronomy, and then a very few number of participants who rated themselves as experts in astronomy. Now, I'm going to get into the results of the individual questions we asked after each sonification. One of which, and unfortunately I don't have time to get into all of them, but one of the questions we asked participants was to rate how much they agreed with the prompt. I learned more about this object, for instance, in our case, the galactic center, through this experience. And we asked them to rate on a scale from 1 to 5, where 1 being they didn't feel like they learned very much, and 5 being that they learned a lot or felt that they did. And I'm throwing up here some histograms of results, so I will describe them. These 3 histograms correspond to the responses of participants for each of the 3 sonifications, from left to right, the galactic center, Cassiopeia A, and the deep field. A key takeaway here is to note that participants across all 3 sonifications and in both the blind, low vision, and sighted groups mostly responded 4 or 5, indicating that they felt like they learned a lot from each of these sonifications. So across the blind, low vision, and sighted groups, the general feeling seems to have been that people had a lot of self-reported learning for each of the sonifications. Participants, however, responded that they learned the most from the deep field sonification. Perhaps this is because it was the 3rd and final sonification they heard, and so they were more familiar with the sonifications at that point. We also performed something called a Kolmogorov-Smirnov test, or a KS test. You can see why we abbreviate it. This is basically a test that two distributions come from the same underlying population. So in our case, what we were trying to test is whether or not the blind low vision groups and the sighted groups' responses seem to be similar, or whether they differed to a statistically significant extent. And what we noticed is that in response to one of the sonifications, Cassiopeia A, the blind low vision group reported learning more from the sonification to a statistically significant extent as compared to their sighted counterparts. Unfortunately, I'm going to skip this just because I'm noticing we're a little tight on time. And so I'm going to just go into the overall questions we asked at the end. So after listening to all 3 sonifications, we asked participants to respond to each of these prompts. 1, after listening to these data sonifications, I am motivated to listen more. 2, after listening to these data sonifications, I'm interested in learning more about our universe. And 3, after listening to these data sonifications, I want to learn more about how others access information about the universe. And again, this had the same rating of 1 to 5, where 1 is they don't agree with the prompt very much at all, and 5 is they agree a lot. Here again are histograms of the responses, though again, I'll talk us through them. Again, as opposed to being a response for each of the sonifications, now these are responses to each of those overall prompts, broken down into the blind low vision and sighted groups responses. Now, if we look at the prompt regarding being motivated to listen more, we note that both the sighted and blind low vision groups respond mostly with 4 or 5s, indicating that they are motivated to listen more. When we look at these other 2 prompts, however, this prompt about being interested in learning more about the universe and being interested in learning more about information access about the universe, this is where things get really interesting, because we start to notice that the blind low vision group reports being more interested in learning more about the universe and about how others access information about the universe to a statistically significant extent as compared to their sighted counterparts. This is really interesting, and we theorize that it's because sonification makes astronomy outreach accessible to blind low vision people, a community that is historically been rather excluded from astronomy outreach due to the predominance of visual media in astronomy. Now, we also asked, as a sort of fun question, we asked participants to list up to 3 words to describe their emotional response to the data sonifications. This is a word cloud where larger words represent more common responses. So the most common responses were things like awe and calm, curiosity, interesting, peaceful, wonder, beautiful, all these really sort of positive, wonderful descriptors. And so if I'm to leave you with some key takeaways really quickly before we get to the questions. First, I would say that both sighted and blind low vision people report enjoying data sonifications. Unfortunately, these are the results that we skipped over for the sake of time, but both blind low vision and sighted participants reported that they enjoyed the sonification. We also found that both sighted and blind low vision people reported feeling like they learned from the data sonifications, though in some circumstances, the blind low vision group reported learning even more than their sighted counterparts. And also, both groups generally wanted to learn more about the universe after listening to the sonifications, but the blind low vision group reported being more motivated to do so than their sighted counterparts. This is an indication to us that sonification increases the accessibility of astronomy outreach. We think that this provides really compelling evidence to continue to include sonification in astronomy outreach because it improves accessibility for blind low vision people, and people generally report really liking it, whether or not they have a visual impairment. I would just like to provide some acknowledgments. We were supported by some excellent programs and also had some great assistance from people at NASA distributing the survey. And this study is published at Frontiers in Communication as of this year. And here's that QR code I promised, as well as my email, which is sgk27@cam.ac.uk, cam.ac.uk.
Thank you so much, Sarah. We do have a couple of questions for you here in our Q&A. The first coming from Academic Crusader, asking, would it be correct that an example of data sonification is the use to radio telemetry when collecting habitat data of wildlife, monitoring social groups of wildlife?
Oh, that's I'm not sure I know the answer to that from that question. I'm sorry to say.
They do have an expanded question. They say, to expand the question, radio telemetry uses an antenna and radio signals, which are made up of invisible and silent electromagnetic waves. Would that also be an example of data sonification?
Yeah, this is actually a great question. Radio waves are actually somewhat counterintuitively a form of light. They're simply a form of light that human eyes aren't capable of seeing. And in fact, in this case, those radio waves are the data. So remember that data sonification is a representation of data as sound. But in this case, those radio waves that are being collected for radio telemetry, that is the data. So it's both not technically a sound, though we do tend to think of radio waves as sound just because of like radios, like the device. But also it's not a representation of the data. The radio waves actually are the data.
Excellent. Thank you so much for not only explaining the data for sonification, but also the science behind it. We have another question here from Gala asking, with a radio dosimeter, the crackling sound or intensity indicates intensity of radiation, which is invisible and communicated for safety reasons. In this research, what is the meaning of sound? Is it assigned for aesthetics? Or how does it communicate access across the population that is new to the sonification of space?
Yes. So in this case, the type of sonification that was used is something called parameter mapping, which essentially means that different aspects of the data are mapped to different parameters of the sound. So for instance, I believe height along the sort of 2D plane of the image, so the image is itself the visualization and not the data itself. This is mapped to pitch, for instance. This is a parameter in the data. Now, to my understanding, that the universe of sound sonifications are used, again, for outreach. So they're meant to sort of educate and share the wonder of astronomy with the public. In the same way that we astronomers wouldn't use, for instance, the beautiful James Webb Telescope images for science for the most part. Those are for public consumption. That is, in my opinion, an incredibly important facet of science, that we have ways to communicate our science with the general public.
Sci Access. Learn more at www.sciaccess.org.